Hello everybody, welcome back to IZ8 DWF Repair Lab. This time we have another wooden box acoustic coupler, probably from the 70s, like the previous one. This one looks like very similar in the form factor, but it's quite different in construction, at least the box. This is Reed and Company Limited, type TC301. Let's see, power cord, UK plug. This will be substituted with this one. By the way, I have quite a lot of a few of this UK plug. If someone want to swap them with something more suited for Italy or Germany, I will be glad. So write me if you are interested. Anyway, back to the modem. We have probably RS232 interface, current loop, full and half duplex, and power on. So this will be surely originate only modem like the other one. This is the headset compartment. One of the latches is missing, so I will try to find something similar. And unfortunately this is completely destroyed. The cups were resting with this kind of form that completely destroyed it. It turned into a sticky goo. Wow, what a mess. So even this part of the other part of the compartment was filled with this kind of foam, probably to allow the handset to rest firmly over the caps. So first of all, I will need to clean this whole mess and find some suitable replacement for the foam. Unfortunately, there are a few pictures on the internet of the inside of this acoustic coupler, so I can guess how the foam should be when new, or well, how it was supposed to be. It will take a lot of time, I guess. Okay, with the help of a lot of rubbing alcohol and quite a lot of time, I've removed almost all the residues of the old foam. Of course, there are residue of glue, but it doesn't matter because I have to glue back another kind of foam. Try to salvage this kind of gaskets that goes around all the perimeter of the foam. They are not deteriorated, but a lot of residue of glue also. Anyway, they will be salvaged. These are speaker microphones. I had also to clean the inside of the caps, microphone and speaker caps. And I'm going to glue back these rubber spacers, and also this one that holds the microphone and speaker inside the caps. That's all in all, it's a good job. And after restuffing the foam with the new material, I can put back the electronics and start trying and troubleshooting if needed the modem. Okay, finally found some foam material. This is a panel of sound absorbing material. It's not very thick. It has self-adhesive back, so try to cut pieces of this material and stuff the cap compartment on the other side to hold the handset when closed. I will cut paper template first with the sides of this box and then use the paper template to cut pieces of the actual material and see if I can reconstruct similar as the original foam configuration that allowed both the caps to move slightly and adapt to the handset. Of course, I will use one of my handset as a template to keep the caps in a suitable position while I construct the material to stuff the compartment again. This is the result so far. It doesn't look very pretty, but the thickness material was probably too thin, so I had to stack various layers and cut pieces. But anyway, the caps can move a little bit, and looks not pretty, but should work. And now I have to trim the excess thickness around the borders, glue back the gaskets. Okay, by removing just 3 screws, 2 here and 1 here, the whole circuit assembly can be extracted from the box. And there is a connector that connects to the microphone and speaker that can be disconnected, so the whole circuit board can be taken apart and inspected. Of course, I will need to reverse engineer all the circuit, and that would be, well, I don't know if it would be easier than the other one, but because there are only 2 circuit PCBs, but there is, I don't know if you can see serigraphy on the PCB, so that would be easier than the other one when there will be no markings on the other one. So reverse engineering starts, and I will also check all electrolytics, all semiconductors for shorts, for leakage, the electrolytics, ESR and so on. That would be before powering on, of course. Very nice construction, very well built. Every wire has its color on the silk screen. Every component, many components are high precision resistors and capacitors. but there are many integrated circuits, very different from the other acoustic coupler that we have seen on a previous video. And this was probably built at the end of 1976, because these two are the newer components, and both are from October 1976. So probably this was made at the end of 1976 or early 1977. But components have all sorts of date codes, starting from 1971. This one. Many are from 1974, 1973, and so on. So they probably have a large stock. So far I'm just checking capacitors, checking diodes, and BJT transistors. So and of course reverse engineering the circuit. Okay, so I finished reverse engineering all the schematic, checked the various components that can be checked without powering it on, and there's nothing really wrong so far. I just sprayed some contact cleaner on the power switch. On the other side there is a opening, because the resistance when on was about 200 ohms, which is not good. When spraying contact cleaner and operating the switch a few times brought back the contact resistance to 0 ohm. So let's power on, and we have the lamp, the on lamp that goes on. The only power supply rail which is adjustable is the +5. I'm measuring 4.91, but maybe I will raise it a bit, but it's already in the right interval. So let's go on. So another thing that we notice when it is on, it doesn't emit any sound when it's a speaker. This is intended actually, because the B21 recommendation is to wait for a carrier in the answer from the answer modem to be received before the originate modem, which is this one, which is originate only, puts out its carrier. So I have my test set up with my little speaker, and let's try to produce the originate answer tone, which is 1650 Hertz. So ticks on. $1,650. Okay, we have the data lamp on now, and I think I can hear, yes, the answer tone, yes, the originate actual tone, and the answer is produced with my speaker, but yes, it's coming from the speaker. So now I have to connect the receiver of the instruments to see if the frequencies are good. Okay, so I tap it directly the instrument to the speaker contacts. No carrier. Let's transmit the carrier, and we have a signal. according to the instrument is 1175 and 475 Hz, which is 5 Hz lower than the 1180, but the 0 tone, it should give the 1 tone when idle, but I have nothing connected to the serial port, so maybe when nothing connected, this modem goes to the 1 or to the 0, I mean, on the serial port. So let's drive the serial port and see if it changes. Okay, yes, as expected, if I connect something on the TX line of the serial port, if I touch the +12, which is that 0, nothing happens, and we have the 0 tone almost. Well, it's a bit lower, it should be 1180, but if I touch the -12, yeah, we have a changing light of the indicator, so this indicates the transmit data actually, and we have a change in tone also, and we have almost the correct tone, well, which should be 980. So now I will try to set correctly the two tones. Okay, it turns out that these two trimmers set the two frequencies. First of all, they are marked also on the PCB side, to the solder side I mean. RV5 sets the one frequency to 980, or almost. Then if I switch to the 0 frequency, then RV4 sets these other frequency, and this should be 1180 or almost. It's okay, let's go on the receive part. Now I'm getting the signal on pin number 3, which is the received signal on the serial RS232. 1650 is the one frequency, and on the RS232 is minus something, yeah, minus 8.8. well, it's enough. So let's go to the 0 frequency, 1850, and I'll show you this light changed again the brightness, but now I'm 1850, which should be a 1 at 0, sorry, this plus changed polarity, so receive part looks good. One last check is the carrier detect signal now is inactive, minus 11 and something. Let's switch on the carrier, and now it is plus 11 dot something, so all in all it's okay. Well, actually one last test is the receiver sensitivity. Minus 51, and it's correctly sensing the carrier. If I go to minus 52, it stops sensing correctly the carrier, so that's very well, very well. It's almost the limit of this instrument, quite the same as the Prentice Star acoustic coupler of the early 80s, so very well. It's way better, 10 dBs or more better than the other acoustic coupler after the problem on the RX circuit was solve it if you've seen the other video. So all in all, well, let's test this. Okay.